Good evening, everybody, and welcome to another episode of vBrownBag. Tonight, I'm excited to continue on the path with our Python for DevOps series. This is going to be another. Let's see, what is this? The fifth episode, the sixth episode? I can't remember right now. We're doing a bang up job with this series. Having a great time with it. Come join us and level up our skills as we learn Python. Tonight, we are going to be doing test-driven development in Python with our presenter, Alex Linck. Before we get into it, a couple of housekeeping notes. Get in on the conversation. If you at vBrownBag or hashtag vBrownBag, I will be watching the Twitters, fielding all of your questions and sending them on to Alex during the live episode. If not, then, and you're watching this in the far, far distant future, you can at Alex Linck or at Alex_Linck directly and ask him all the questions. I, of course, am Mistwire. And without further ado, Mr. Linck, are you there?
I am here.
So now that I've said that 17 times, is your last name pronounced Linck?
It is Linck, yes.
Thank God. Okay.
Yeah, surprisingly few people get that right. It's pretty amazing.
All right, sir, you have the power.
I have the con, all right. So, it's my screen. So this is...
I see it. VS Code, I love it.
All right, yeah. I sort of switch back and forth between VS Code and PyCharm. I figured VS Code would be better for presentation. It's a little bit brighter and more view friendly.
Less widgets along the sides.
Yeah, less bells and whistles. Yeah, today, what I wanted to talk about is test-driven development in Python. Just sort of going over the basics of it and what it is and why it's great and what and why you should employ it, or anyone doing any kind of programming, not just in Python, but any kind of language, should, if they can, employ it to its fullest extent, because it is a way of writing the tests, the unit tests first before writing the production code, and that is what that does is that it allows you to sort of think through what you want your code to do and sort of describe your behavior, the behavior that you expect from your code before you actually write the code to actually do that. So that way you say, all right, I want my code to do this particular thing. You write the test, you run the tests fail, of course, because you have no code, and then you write the code to make the test pass. And once the test passes, you're like, all right, it's doing exactly what I want it to do. And the added benefit to that is that once you have your production code and your tests in place and everything's passing, then you can go ahead and refactor and clean up your code and do whatever you want to it. And as long as the tests still pass, you can be assured that everything everything still functions, and you have nice clean production code that you can push out the door. So that is what test-driven development is, and that's why that's why you should use it, and sort of learn how to use it and use it. It does take a little bit of practice. I didn't even know what it was before I started my current job at Profit Tools. Our senior developer, he's been programming for over 30 years. He's a devout follower of Uncle Bob Martin. For anyone who doesn't know who that is, he is a sort of a coding test-driven development evangelist. He's an old man. He's been around for a long time, but he's a very good educator, and I would recommend everyone sort of look up his stuff if you want to learn about clean code, solid principles, and all that.
What was that name? Uncle Bob?
Uncle Bob. Yeah, he goes by Uncle Bob. His name is Robert C. Martin.
Uncle Bob Martin.
And, yeah, Bob Martin. He's an evangelist for clean, solid code. And yeah, if you're interested in learning how to write like really clean, maintainable code, you should definitely talk to him. But like I was saying, our senior developer is a devout follower of solid principles and clean coding principles. So it was kind of a steep learning curve when I started my current job because I was not used to that. I started off at a startup. My first job was at a startup, and it was pretty much just, all right, we need it to do this. We need this feature now, get it done. So you just, all right, and you just slap something together, and as long as it works, you shove it out the door. And it was a total gear change when we moved, when I started my current job. And I said, I'm 35. I've only been a professional programmer for about 2.5 years. So it is really, I'm glad that I'm learning this now, sort of at the beginning, more at the beginning of my professional career, before I get too set in how I like to do things, because it's definitely been a learning process. Working with my senior developer, who's sort of automation, lightweight automation library I'm actually using here for this demonstration. This, and I will sort of explain what this is. This bolt file. This is a configuration file for bolt TA. I'm guessing, I was kind of surprised to see on a previous episode we had the developers of Bolt, which is a very similar thing. He may have named Bolt TA because Bolt was already taken. So yeah, it was. It is just it's sort of a lightweight automation framework. You can we use it mainly for testing, but you can also integrate it in with Jenkins, and sort of have your Jenkins call, Jenkins file call your Bolt tasks, instead of having to put in every so that you already have everything configured and the way you want it. So everything is the same. You use Bolt in Jenkins, you use Bolt in your production, in your dev environment. So it all installs in the same places and works the same way. But what I have this set up to do is, well, actually, I have not yet activated my. I have my. I have this posted. I have actually the code posted to GitHub. So I had just loaded it onto my machine. I haven't yet activated my environment, so let me go ahead and do that. And okay, so got my virtual environment now. I'll just do my pip install, because I don't actually have any of my packages installed, which by any I mean Bolt, TA, nose, and contest. Contest is for continuous testing, which is a wonderful thing for test-driven development. What contest does is it's a plugin for nose that will monitor your files, the files in your project, and when there's a change to one, it will rerun all your unit tests. So that's a great thing for that way you don't have to constantly just be running, manually running your tests, your unit tests. So pip install our requirements. So yeah. So yeah. So here we are. Everything should be installed, and so I will go ahead. I've got my source and my tests here. This is what the final code will look like. But I'm going to delete all of this, and we'll start from scratch, more or less, so that we can sort of go through what test-driven development is, and why it makes the development process a little bit actually easier and cleaner, and why it allows you to make nice clean code. So I'm going to start off just by creating two classes, one in my my source file, my production code, and one in my for my testing. And all right, so I currently don't have any tests, so let me start the all right, so ran zero, got my tests running, ran 0 tests, so it's because I don't have any. So everything's working as expected. So, I mean, fast start. I mean, right now that knows you have your setup, I know that I'm going to need um, an instance of my bowling game class. Oh, I should probably explain what exactly I'm going to be doing. This is this bowling game is a code kata. It's going to the point is to create a bowling a calculator for bowling scores, and because it's you've got your roles, which is separated into frames, which and when you get if you don't add up to 10, if your rolls don't add up to 10, then it's just those together. If you get a spare, it's 10 plus your next roll, and if you get a strike, it's the 10 plus your next two. So this is a kata to sort of practice that, to think through the process, and to sort of, I guess, anyway, just to be able to solve that problem. And it's a really good one for test-driven development, because there is quite a bit of like sort of going back over your code and refactoring. Nice. while you're typing. So right now I've just got a passing class. I've just got that, so it doesn't give me errors. But let's see, setup. I will say self game equals bool. Let's see, sorry. We've got it say, bool dot, what do I call it? My goodness. Yeah, bowling game. And that's going to fail probably because, it doesn't, because I have it initialized, but it doesn't have an init. So anyway, normally, if you're doing it right, you wouldn't have a bowling game class, and it would fail. You'd create one, it would pass, you'd move on. Anyway, there's that. I will go ahead and so that's my tests are passing, or ran 0 tests, but my code is passing anyway. So I'll write my first test. Test. We'll say the first test would be rolled all zeros. Test roll. Roll all gutters.
Mm-hmm. Yep.
So I'll say. All right. So I feel like I'm trying to talk faster. I've tried to talk too fast.
No. You're fine. You're just to let you know, your Discord is popping off. There's somebody trying to chat with you.
Yeah, I'm going to go ahead and close that. Discord is constantly talking to me.
I have friends that if they know that I'm hosting or presenting, they will deliberately try to send me messages while my screen is being showed to see what they can get away with. So
it's like I've been there with like work presentations and stuff like that. Popping up like, oh yeah, you just won this, Xbox or something, sending me messages during my work presentation. It's great. It's super comfortable. Anyway, the bowling game, we know we're going to need, say, it's bowling, so we know we're going to need to roll. We're going to need to roll some balls here, and so we will say that itself, and we're going to need to know how many pins we knock down in each roll. And we're going to have to actually calculate the score. So we are going to need a score method as well. Now, test roll all gutters. So we're going to say we're going to need to roll 20 gutters. So we'll say self game dot roll 0. But instead of, there's 20 frames, or 20, a maximum of 21, not frames, roles in a game. So I don't want to type self game role 21 times. So I am going to say, I'm going to add a little method here. It says def, role many. It's going to take self. It's going to take roles, and it's going to take, roles, and it's going to take the pins for each role. So let's see. We will say self dot for role in roles, self dot game dot role pins. So that should allow us to roll however many times we want, as long as it's the same amount. So we'll say self dot roll many is 0. And we're going to want 21, or 20. Sorry, there's only 21 if you get all strikes. 20 and 0. So so we have now rolled 20 gutters, and we're going to want to test the score. So self dot game score. Oh, I need my assert. Self assert equal my score, and we're going to expect it to be 0. So go ahead and save that. Actually, I'm going to move this over here. Wake up. There we go. Anyway, so int object is not iterable, right? So roll and rolls. I can't. So I'll have to say in range. My mistake. Anyway. So that. Okay. Ran 1 test assertion error. None is not equal to 0. So good. We are not actually returning anything from score. So we're getting none. That's good. Good start. Now, in order to make the test pass, I'm just going to say, we're starting off real simple here. So roll, we'll just say we'll give it an init. We will say, we'll say self. We'll give it a self dot score. Set it to 0. For the roll, we will say, self dot score plus equal pins. And for score, we will say return self dot score. All right, 1 test passes. We're okay. So, so we now have a passing test for an all gutter game. And when we add the test for, so we'll say next one we'll say test, roll all ones. We'll do self, roll many. We'll say 20, and we're going to want to roll 1. And then our assert statement, self assert equal and score, we're going to expect it to equal 20. So that passes because I guess I did skip a little bit and not write the minimum code required to pass. What I would have done in that case is to write return self 0, because that would technically get all my all gutters game to pass. So I could just say return, I go back to what I was doing, say self score. Actually, I'll say return 0. This will cause my current test to pass. The roll all once. Yep, 0 is not equal to 20. So I'll go ahead and redo that self.score. Yeah, the point is, which again, I'm not perfect in my test-driven development, but the point is to write the minimum code required to make your test pass. And if that's just, if you're expecting a 0 and making your test pass just says return 0, even though that's not how you're going to end up, that's still what you should do. And then once that test passes, you can then write a further test, a more specific test to say to make that test fail. Anyway, so my all ones is passing, so it's doing addition properly. That's good to know. And so if we say, we start making it a little bit more complicated, we'll say roll one spare. So I will go ahead and say self.roll many, no, sorry, self.game. I'm just going to want to roll. So I roll 5. I'm going to want to roll another 5. And then I'm going to want to roll one more, since I need to calculate the frame. Oh, goodness, what happened? All right, sorry. And then I'll roll a 3 after that. So I now expect my score to add up to 5 plus 5, 10, plus 3 is 13, plus 3 would be 16. So self.assert. I got my assert equal and I expect that to equal 16. Because you take 3, you add it to the spare, that's 10 of the spare as a bonus, plus 3 of the next frame. We expect that to be 16. So right now, 13 does not equal 16. So we don't have the logic to actually calculate that extra bonus. So what we're going to have to do is look at this and see what we're doing here. So what is strange here is that score is actually just returning score. It's not actually doing anything, and actually your roll seems to be calculating your score. So we're going to do a little bit of refactoring here. I'm going to comment out my test, failing test, so that everything passes. And we're going to change this around a little bit. So I'm going to sort of keep track of my rolls instead of my score, because we know we're going to need to do that to calculate the frames, because we need to know the frame. We need to know what comes next, and we can't do that the way we're currently doing it. So I'm going to create Selfrolls, and I'll go ahead and make that a just an array of 21 element array of zeros. So now I have, Selfrolls will be a 21 zeros, an array of 21 zeros, and just essentially a blank game, my gutter game. And I'm going to have to keep track of what roll I'm on. So roll equals 0. So in order to keep track of my rolls, I'm going to have to say let's see, self dot roles index my current role equals pins. So that's just going to keep track of my roles individually. That way I can reference what comes after. And in order to calculate the score, actually, I'm going to have to increment my current role. So almost forgot. But the test would have caught that. So I would have had failing tests. So if that had happened, so that's sort of what the point of this, all of this is. So my current role plus equals 1. And then to calculate the score, I'll say, for role in roles, in Selfrolls. Sorry, let me put in my score. I need to keep track of that score. Role in self dot roles score plus equals roles return score. All right, let's go ahead and make sure I did that right. Did not. Name roles is not defined. Right. Score role, not roles. Delightful. There we go.
Nice.
So, yep. All right. So that's
quick question from the audience.
Yep. Sure.
This is more of a broader strokes one. How does test-driven coding help when you need to refactor a function to require additional parameters, or needs to return additional data in a return structure? How would it help you in that event?
Yeah. So that is a good question, because when you do test-driven development and you are testing your functions, you are testing the public interface to your functions. So if you changing the parameters is changing the public interface. So that would be something that you'd have to do the same thing. You'd have to change your tests first to require that additional parameter. To test for that additional parameter, your tests would then all fail, and you would change your production function to make those tests pass. But that is a good question. But the principles remain the same. You change your test if you have all your tests written already, but then you have to change the public interface. Then you change the public interface of the test in your tests, and then change your production code to make your test pass.
Gotcha. Cool. Thank you.
Okay, you're welcome. So, yeah, moving on. We'll go ahead and uncomment this test. So we'll get our failing scenario again. And so now we're back to 13 does not equal 16. That's good. And so we are now. It seems like right now we're going to need the concept of frames, which I probably should have done before, but we have our tests there, so I'm going to go ahead and comment that out again, and refactor this to use frames, to use the concept of frames anyway. So that way we can add our bonuses accurately. So we will say, just say for frame in range 10, since there's only ever 10 frames. We will say score plus equals self roles. Sorry, I'm going to need to keep track of an index. Yep. I equals 0. So say self roles I plus the next one, because we're going to want to calculate these two at a time. or one frame at a time. So self dot rolls I plus 1, and return score. Oh, and we're going to want to I plus equals 2. We're going to skip ahead 2 so that we don't count the same frame twice. And we have our passing tests. Good.
Ooh.
So, all right. There we go. Wrong button. There we go. We're going to bring back our failing test. Now we're back to 13 does not equal 16. So now that we have this, we can go ahead and check to see if our two rolls add up to 10. So if Selfrolls I, if Selfrolls I plus 1 equals 10, score plus equals 10 plus Selfrolls I plus 1. No, I'm sorry, plus 2. And then, and then I plus equals 2. Else, we do the normal thing. So, see, did we make that test pass? We did. Fantastic. So we have our expected score of 16. Now, what happens when we roll a strike? So we'll go ahead and say self that game roll 10, and then we can go ahead and say self game roll 5 and 3. And also, now that we have our entire game built over here, we don't have to go ahead and roll all zeros after that, since we already have all the zeros after that. So, I'll keep this roll many here, even though it's not necessary anymore. I would keep this roll many here, just so that you know what's going on in the test, even though it's not necessary. It's illustrative. So now I have my strike, my 5, my 3, and the rest would be 0. So I'll just say self. I'll do my equal. Self.game.score, and I expect the test. I expect it to be 10 plus 5 plus 3, 18 plus 5 plus 3 comes out to 26. So I expect my score to be 26 after that. Game that started off real strong and just went the heck afterwards. So, all right, 18 does not equal 26. That's good. That's expected. So I'll go ahead and add another statement up here. If self rolls, self. Sorry, not I want I. Self.rolls I equals 10. Say score plus equals 10. Yeah, I'll go ahead and do this and change my what's going on? Ah, there we go. Little hiccup. I'm going to change this to I plus 1, and then I plus 2, because we want our next 2 frames. And we will increment I only by 1 since the strike is the entire frame. So let's see. I do have my passing test. Now, it's a little bit kind of hard to read and also a little bit annoying to be typing Selfrolls I+1, Selfrolls I+2 for that. Mostly it's just a little bit hard to read. So I'm going to go ahead and refactor some of this stuff. So I'll start with strike. If Selfrolls, we go ahead and create a function and an internal method called isStrike. It's going to take an argument of your index, and I'm going to go ahead and bring this down there. Sorry, I need to add that. So I'm going to go ahead and return that Boolean. So for our I equals 10, it'll return true. We'll get to run that code. So if self, it doesn't necessarily make a code shorter, but it does make it more clear what's going on. And if you're writing code that you think you might want to touch again sometime in the near, medium, distant future, you're going to want to make it as easy to read and comprehend as possible, because you're going to, next time, if you wait a while to touch your code, like you said that this has happened to me, and I'm sure it happens to everybody. When you've written something on your own and you go back to it a month, 3 months, a year later, and you look at it, you're like, oh my God, this code is crap. How could I have written this? You're going to want to make it as easy.
I say that all the time. It's so weird.
Yeah. How could I possibly have written this? This is garbage. You're going to want to make this as easy for your future self to read and get back to you as possible, and refactor and go ahead and make better, because test-driven development doesn't guarantee that your code is properly structured, or all it guarantees is that it works, and it allows you to make it easy to read and make it easier to read and make it easy to refactor without breaking anything. Because sometimes, I know my first code, I wrote, it was, when I first started coding, my algorithms were just these really long functions, just like, dozens of lines long, like nested for loops and ifs, and just all in a single function. I have since, they're long gone now. I went back over them, like, wow, I don't even know what to do with this. It's like no tests, nothing. It's like it works, but I can't touch it because I don't know what any of this stuff does anymore. So if I touch it, it's gonna break, and I just have to leave it the way it is. So this is a good way to avoid that. Avoid future you getting really mad at current you. For the way that you wrote your code. So for how bad you were at coding. So we have where was I? Oh yeah, if self, just say self, if self is strike, and I pass it the index. So yeah, now we have that, and I'll go ahead and take this this here and call it say strike bonus. So that we know what exactly we're doing there. That's also going to take I, and it's going to need self. So we got, let's take that, cut it out, say return. We're going to return that here. So yeah, now we have that. We've encapsulated that. Now we know Selfrolls I+1, Selfrolls I+2 is our strike bonus. That's why that's there. So, and we'll say self. There we go. I. So, and we'll do the same thing with the spares. Actually, I did that. Let me make sure that the test still passes. It does. Okay, good. So this it's good. It's like a safety blanket. Coding with TDD is like you're like Linus with a blanket, and nothing can ever go wrong. I mean, that's not true, of course, but it just feels safe. Just to have that net underneath you to catch you when you do something silly, which happens, as I can attest, quite often. So it's good to be like, oh, and when all of a sudden your test failed, you say, oh, what happened? And you say, oh, I completely forgot that very obvious thing now that I look at it and know that it's wrong. So I'll say let's say the same pattern is spare, pass it I, and return this, geez. Come on, code.
Control Z for the win.
Yeah, my home mouse is way more sensitive than my mouse at work, so I wish I had my work set up at home, actually. So yeah, I have that, and I'll say if self is spare I still passes, good. I'll say def, do the same thing, spare bonus. Notice I'm not adding tests for any of this because, like I said before, we really are only testing our public interface. We only, roll and score are our public functions, and that is what we are, our public methods, and that's what we are testing. That's what we have our tests for. That way, you're only testing these outer ones, so you can change these inner ones, you can change the inner workings around as much as you want without having to worry about breaking your breaking your tests, and also not just breaking your tests, but breaking the interface that your class or your function has. So anything that's calling it, anything that's using it should still work because you're only changing the internals of it and not the actual public interface. So go ahead and return that spare bonus, which is only the I+2, but we're going to put that there anyway. And all right, so now we have all of our passing tests. Now we'll just create another one, make sure we're doing everything right. We'll say def test all strikes. Go ahead and bowl ourselves a perfect game.
If only.
Yeah. If only were that easy. We're going to go ahead and roll 21 times. We're going to roll a 10. No, not 21. 11, 12, 11. Nope. Yeah. 11. Right? Am I right? We'll find out.
1, 2, isn't it?
It could be 12.
Oh, yeah, up to 12. Right, for the 300.
Yeah. Yep. Yeah. So I'll change that in just 1 second. Self assert equals self game score, and we'll say give ourselves a nice round 300. So is that 11, 10? We're on a list index out of range. Okay, we'll go ahead and say put 12 in there, but say list index out of range. What mistake did I make? Is spare. Return Selfrolls I plus 1 equals 10. Okay, so what did I do wrong? Oh, but anyway, I know now that I've broken my code, which is great.
I think when you cut and pasted the Selfrolls I+2.
Yep, that was the wrong thing. That was the wrong one. Yeah. Well, no, it's not the I plus 2 Selfrolls. Return Selfrolls I plus 2. That is the number we want to add. So spare bonus. So is spare. We are ending up with an index out of range. Why does it think that we are rolling any spares? Is strike. Return roll I equal 10. Yeah. Why would it think we're rolling a spare? Wait. Test all strikes. Yeah, why does it think we're rolling a spare? Let's find out. That's, yeah, okay, that's super interesting. Yeah, spare, rolls I, so I plus 1 equals 10. Yeah, we shouldn't be hitting that. Interesting. All right, so we seem to be, if I comment that test out, we still get that error. Nope. Okay, that's weird. Now that's weird. So why on earth are we? Why on earth are we? All right. Well, that's very interesting. Anyway, so got our list index out of range. Oh my god, this is weird that happened. Return Selfrolls plus Selfrolls I plus 1 equals 10. That's our Boolean. And is spare. So it's testing to see if it is. Oh, that's because I didn't make this an else if. Oof. Oh, good. 5 passing tests. It works.
Oh, so obvious.
Ooh. Yeah. Yeah. Well,
I'm totally joking.
Yeah. Ooh. Yeah. So anyway, hey, test-driven development for the win.
That's right.
Yeah, my code was broken and not in a super obvious way. So, yeah. So now it works. I can roll zeros, ones, spare, strike, all strikes, and really, we're done. We're done here. I mean, I could refactor this out to say to roll a spare, but I don't think that's super necessary. So I'm only doing it once, but that's really it. There's really no other tests that we could write that would fail.
No, this is fantastic. This is awesome.
Yeah, we can't write any more failing tests so to accomplish our goal. So we are done. That is the bowling game. That is the bowling game kata, and that is also the sort of the basic demonstration of what test-driven development is, and why it's useful. I wish I could have made some more mistakes to better illustrate why it's how it's good at catching those like typos and simple mistakes. But that's sort of my demo for now.
A couple of questions.
If you want to elaborate on anything, yeah.
Yeah, definitely. What is the usual code to test ratio, or does that depend?
That really depends on what your code is doing. If you've only got, like, say, you've got a controller, and all your controller does is call one method in your model. All it does is call one method from another class. All your test would do is test that your controller calls that method from another class. So you would let's see, let me see if I can give a quick, I'm not going to write any tests or anything. Let's see if I can get a quick visual of what I'm talking about. Yeah. So we've got a, blah. So close. So we've got our def class some controller, and all it needs to do is call create object. All it needs to do is get object. So, and the only thing it does is say, and that get object, takes that object because of, dependency inversion. So, dependency injection. So we say object, object storage, or just say storage anyway. So whatever it happens to be, a cache, a database, whatever. It doesn't really matter for this demonstration. Then all we do is say return storage dot get, and whatever that model returns, it gets back. For something like this, you would just have a test, that says, test. You just say self, or you'd create a double for your storage, because one of the things about unit tests is that you want them to be self-contained. You don't really want to be interacting with external resources in your unit tests. That's what feature tests are for. So you would mock your storage, put a method in there that says, we'll just say, I'll just, for storage double. And we would put a method in there that we put we'd say init, self, and say, self dot get invoked equals false. Then we would go ahead and override our storage's get, and just say, return self, but we also want to say self dot get invoked equals true. Now, and then once we do that, when we call, when this runs, it calls storage dot get. You can then assert that get invoked is now true, and you know that your controller is working because it called get on that storage object it was given. So, that's that. I may have started to go off on a little bit of a tangent there, but I just wanted to, that's how that particular thing goes. I don't know if there's any more questions.
Yeah, one more question about the katas. Somebody was asking what is a kata, and are there different katas for different experience levels?
Yeah, absolutely. And katas are not intended to be difficult. If you just look up code katas, there's a few different sites with some different code katas. There's there's like a binary search code kata, and there's and there's this bowling game, and then there's like grocery store calculator katas. What a kata is intended to do is it's something you're sort of intended to do. You're meant to do it over and over again. So you start to get in the habit of approaching, you see the problem and you say, oh, I've seen something like this before, and you've already practiced creating the solution to that.
Mm-hmm.
So you can be like, all right, I did that before. I've done that before, and the way I solved it was doing it this way. And since you've already practiced it a bunch of times, you can get that implemented fairly quickly and fairly cleanly. That's what the katas are for. They are not. They are beginner friendly. There is nothing, for the most part. I'd say they're not intended to be difficult. To test your programming skill. They're more. It's like a kata they're called katas for a reason. It's repeated motion. It's something you do over and over again until it becomes natural.
Here we go. Code Wars, Code Kata, Coder Dojo, Simple Programmer. There's a bunch of them out there. Okay, cool.
Yeah.
Nice.
Yeah.
Those are the show notes.
Yeah, great. So yeah, those are the katas, and I would recommend that anybody sort of take a look at them. It gets you thinking about different problems and coming up with good solutions. I think Code Wars. I think was it Code Wars? I'm trying to remember a site that I've been on before that, they give you these sort of these coding problems, and then you can sort of compare your solutions to other people's solutions.
Yeah, that was the first one in there, and there's a ton of different languages.
Yeah, but that was a good one too. I haven't done that particular one recently, but I did that a lot when I was first learning to code. Just because I was stuck in that beginner's stage of, okay, I've sort of learned the syntax of how to code. I know my for loops, my ifs, my whiles, but I had no idea like what to do with all of that. Because I was I'm a little envious of coders, of programmers like your last guest, who sort of come at coding with a problem to solve because they have a problem to solve. So they sort of just can go right at it. Whereas when I started to code, I came at it. I had a different career. I came at it out of curiosity. It seemed interesting. It seemed like a useful skill. So I started to learn it. But then I went through Code Academy and just sort of learning your basic coding. And then I got to that point where it was like, all right, I want to write something, but I have no idea what or how. So it actually took. It's a kind of a little bit of a funny reason that I wrote my first program. It was this very short program, but I accidentally deleted all the pictures on a flash drive that we had, and my wife got upset, let's say.
As she would.
Yeah. So I ran it through a recovery program. It found all these files, but I couldn't open any of them because there was, as I started digging into it, there's just a whole bunch, like kilobytes of just junk data in front at the beginning of the file. You couldn't even recognize them as JPEG. So what I did was I found out what the binary header is, the header bytes for a JPEG file are. I did a regex through this string of garbage looking for that header, and then would delete everything before that. And I would give it, I coded it so that it had a basic interface. I used, I think PyQt, and I gave it sort of a basic interface, and so that I could give it a folder full of these files. It would fix if I would get the first file, fix it, save it, move on to the next one, and just do that, because there had to have been 1,000 pictures on that thing. So I could have gone through and done it all manually, but I really didn't want to. So that was the sort of the impetus to get my first coding project up and out the door. And that was it was fortunate for me in that it sort of got me started. I started to realize, okay, I know I can do this. I can just do I can do my basic automation. I can do, I can start to see what problems there are to solve. Whereas before I was like, I have no idea what to do. And now, say, I don't know, my most recent one, that I'm still working on actually, but it's actually a web scraper to that it goes out and it gets all the info for, say, all the soccer players in Europe, like every single one. There's like over 17,000 of them that I got data for, because my kids during the World Cup kept asking me questions about these different soccer players, I had no idea who they are, but it's like, yeah, who's the tallest soccer player? Who's the oldest? Who's the who's the youngest? I have no idea. I have no idea, and I wanted to sort of get all that information in one place. So I wrote a web scraper to get all that information, put it into a database, and now I can run queries on that database if they want to ask me, like, who's the oldest player? I'd be like, oh, well, I'm just going to sort by age. All right, this guy is the oldest one in the European Football Association. So
very cool. And your wife's happy, and your kids have some additional knowledge now. That's excellent.
Yeah, my wife's happy because we got her pictures back, and my kids. I could have quick answers to my kids' questions. Yeah.
Cool. All right. Well, we're coming up to the top of the hour, so we need to nip this one. We do not have any additional questions, but Alex, this was absolutely fantastic. Thank you very much for spending some time with us tonight and showing us around. This was great.
All right. Well, it's my pleasure.
Cool. Thanks.
It was really fun.
Everybody have a wonderful evening, and we'll see you again next Wednesday. Take care.
All right. Take care.